Here in Chapter 6, we're working with rational expressions, which is the fancy term for fractions that have polynomial numerators and polynomial denominators. And when you learn to work with any new thing, the first thing you have to learn is how to do arithmetic with that new thing. So you have to learn how to add or subtract or multiply or divide. We're going to start with multiplying and dividing because when you're working with fractions, multiplying and dividing is easier than adding and subtracting is. So, to refresh your memory, back when you learned to work with numerical fractions back in elementary school, multiplying could be done two different ways. One way of doing things was considered sort of the direct, basic way, and that's where you take the two fractions and you multiply together the numerators and you multiply together the denominators. So in this case, we're doing 3/8 times 2 9s, and when you multiply 3 times 2, you get 6. When you multiply 8 times 9, you get 72, so your answer is 6 over 72. But like in this example here, one thing that happens most of the time is you end up with something that can be reduced. So there's almost always a second step where you have to reduce the fraction you've created. So multiply tops, multiply bottoms, and then reduce. In elementary school, you probably remember learning a more sophisticated way to do this problem. That is essentially where you reverse the order, where you reduce first and then you multiply tops and bottoms. And the key to this is the idea that you can cancel a numerator and a denominator even if they're not in the same fraction. Like in this example here, we're canceling the 3 and the 9, even though they're from two different fractions. And we're canceling the 2 and the 8, even though they're from two different fractions. And then the multiply the numerators and denominators is a lot easier because the numbers are smaller. So you would have 1 times 1 is 1, 4 times 3 is 12. Pretty good chance that you were given a name for this, and the name was probably cross-cancellation. But it really isn't important what the name is. Not every school uses that name, so where you went to elementary school, it might have been called something else. The name is not important. The idea, though, that you can cancel numerators and denominators before you multiply the tops and bottoms, that's the important idea. Now, in elementary school, with numbers, you could do things either one of those two ways. That's not going to be true now that we're in algebra and we're working with polynomials. Take a look at this problem. We've got one fraction over here on the left, 10x plus 20 over 2x squared minus 3x plus 1, and we're multiplying by another polynomial fraction over here, x squared minus 1 over 5x plus 10. And if you try to do things the basic way, where you multiply the tops and multiply the bottoms, you get a mess. Now, multiplying is not hard. You can take 10x plus 20 and multiply by x squared minus 1 and just FOIL it out. That's easy to do, and you get 10x cubed plus 20x squared minus 10x minus 20. Same thing in the bottom. You multiply that out, collect your like terms, and you get that in the denominator. But then, how do you reduce that? The numerator there is very complicated. The denominator is very complicated. Trying to get that thing reduced using the techniques from section 6.1, that would be really rough. You'd have to factor that big clunky numerator, you'd have to factor that big clunky denominator, and then hopefully find things that matched up so you could cancel. So that's not really a good way to do the problem. In order to work with multiplying polynomial fractions, we really need to depend on this cross-cancellation idea. That is definitely the better way to do these problems by a long stretch. So, working the same problem, here's what it would look like if you reduced first, which in this case requires you to start with factoring. And that's 4 factoring problems instead of 2 factoring problems, so that's a downside, but they're all very simple factoring problems. 10x plus 20, you just factor out 10. X squared minus 1, that's a difference of squares. That factors x plus 1, x minus 1. 2x squared minus 3x plus 1, that's a little challenging. That's true FOIL factoring. And 5x plus 10, you just factor out the 5. let me pause for a second and point something out. Back when we were learning factoring, back in Algebra 1, your teacher may have told you that factoring was really important, and you may not have seen why. You're starting to see why here. In order to do this one problem, you have to factor 4 times. So that means you really can't be kind of weak at factoring. You have to be strong at factoring in order to be able to do this problem easily. Once you've got the thing factored, as long as you realize you're allowed to cross-cancel, the canceling here is pretty easy. X plus 2 will cancel x plus 2. X minus 1 will cancel x minus 1. And don't forget number cancellation. It's not just polynomial cancellation. You've got a 10 and you've got a 5. Yeah, you can cancel the 10 and the 5 just like back in elementary school. You're going to get a 2 and a 1. Once you've got all that stuff canceled out, then you can multiply the tops and you can multiply the bottoms, and that works out really easily. In the top, the only things that we don't have canceled are the 2 and the x plus 1, and that's it. And in the denominator, we have a 2x minus 1 and a 1. There's really nothing else in the denominator. So one thing that might be a bit of a question is, how do you write your answer when you're done? Do you write your answer like this, or do you write your answer like this, with everything multiplied out? Do you factor the top and bottom and leave pieces factored out? Or do you multiply out the top and bottom and leave everything multiplied out? Some classes are very picky about which format you use, and when you're doing your homework on the computer, you can be pretty confident that the computer will be picky. But the problem is they're not always picky for the same thing. Sometimes they're picky and demand the top version, and sometimes they're picky and demand the bottom version. So if you're typing an answer into the computer and it doesn't like it, try the other version and see if maybe it's being picky the direction you're not expecting. In terms of writing on paper for tests in this class, I don't care. Write it either way. Leave everything factored in the top and bottom, multiply out the top and bottom. I'll take either one. So don't worry about which format to put it in. Just make sure you've done all the canceling and you'll be okay. So let's practice a larger and more complicated one. So this is one of those problems where you might want to pause the video, take a little bit of time with your own piece of paper, see if you can factor all 4 parts here and do all your cancellation, and then multiply it out, and then press play again, and I'll work it through and see if you get the same thing that I get. Alright, so when you're factoring the numerators and denominators of these polynomial fractions, this first one factors into x plus 4 times x plus 3. The second one factors into x plus 2 times x plus 4. This one up here is a difference of squares. It's probably the easiest one we've got, so that's 2 minus x and 2 plus x. And then this last one down here factors x plus 3, x minus 2. So that's the hard part of the problem. If you can factor those 4 polynomials, the rest is easy. The rest is just cancellation, and that's almost fun because it's really obvious and simple. X plus 3 cancels x plus 3. X plus 2 cancels this, because notice this is technically also x plus 2. 2 plus x, x plus 2, it's the same thing, so those will cancel. Of course, the x plus 4 and the x plus 4 cancel. And it's possible you may have stopped at this point and thought you were finished. And if you did that, you're mostly right, but you did miss something. There was a key idea that you missed, and that is, notice the tops and bottoms are opposites. And we were talking about that back in section 6.1. If the top and bottom, the numerator and denominator, are exact opposites, the 2 is positive versus negative, the x is negative versus positive. If you've got exact opposites, those cancel to -1. So that fully correct, the simplest possible answer you could provide to this question would have been -1. Okay, one more example for you to practice. Try this one here. Again, pause the video, work the problem through, and then press play again and see if you get the same thing I've got. Before you press pause, I'd like to mention there is one tricky part. Let's see if you catch it. Okay, go ahead and work it on your own. All right, did you catch the trick? It's a division problem. And you might feel that that was kind of unfair that we haven't talked about division problems yet. All we've done is multiplication problems so far. But remember back in elementary school, when you're dividing fractions back in elementary school, there was a certain thing you did back then. We're going to do the exact same thing here. So if you thought maybe you could do that thing from elementary school and you tried it here, you were right. Division converts into multiplication. The way it converts into multiplication is you leave the first fraction alone. You just sort of copy it down. So the numerator is still 8x cubed plus, or x cubed plus 8y cubed. The denominator is still 2x squared plus 5xy plus 2y squared. It's multiplication now, and the second fraction gets flipped upside down. This is described a lot of different ways in different elementary schools. Some schools teach this as multiply by the reciprocal. Some teach it as copy dot flip. Some describe it as convert to the inverse. I'm not too concerned with the names or what you remember it as, but do remember the first fraction stays alone, the second fraction is upside down, and it turns into a multiplication problem. So if you weren't sure how to get started, you may want to pause the video again now that you know what to do first. Try working the problem, and then I'll factor it out and catch up with you. Okay, so this first numerator is a sum of cubes. So the sum of cubes shortcut is a little trickier. When you factored that one, you should have gotten x plus 2y times x squared minus 2xy plus 4y squared. The second one is a more traditional type of factoring, just a regular trinomial breaking up as two binomials, regular old FOIL factoring, and that factor is 2x plus y times x plus 2y. The second one over here, or the second fraction's numerator here, first you should factor out a 2, because there's a common factor of 2. And then what's left is a difference of squares, so you should get 2x plus y times 2x minus y. And then that denominator we've got there has a similar sort of a trick going on. First factor out a common factor of x, and then what's left is regular old FOIL factoring. Oh, wait a sec. No, it isn't. Try breaking it up one way and it doesn't break up. Try breaking it up another way and it doesn't break up. You probably got really frustrated, and the reality is it just doesn't factor at all. You factor out the x, and what's left, x squared minus 2xy plus 4y squared, is prime. That part won't factor any further. Now, regardless, you can still cancel that large expression, x squared minus 2xy plus 4y squared, with this piece up here, because they match. Whether they factor or not, they match, and you can still reduce. And then there's all the rest of the regular cancellation, x plus 2y and x plus 2y, and 2x plus y and 2x plus y. When you're all done, you should have 2 times 2x plus y in the numerator, and just regular old x in the denominator. If you prefer having everything multiplied out, you would write that as 4x plus 2y over x. Either one of those is an acceptable answer. Those are both considered correct answers to that problem there.